Okay, so this is the last lesson in Unit 9, and this is finding trig functions at any angle. So if we remember what we talked about last time, let me zoom in here, okay, about sine and cosine, we remember that because of the way trig ratios work, when we are using the unit circle, sine of theta just ended up being the y value, and cosine of theta ended up being the x value. And so we were able to do sine of whatever angle on our unit circle, and it was just the y coordinate of that particular angle. And same thing with cosine. So today we're going to look at any of these angles, but one of the things we're going to do is change the radius on you. So if we can find it with any angle and also any radius and how that looks on our unit circle. So first off, we need to understand sort of how this works. So I'm going to draw just in here a circle. So if I have a circle on a coordinate system, okay, when you go to do a particular angle, whatever theta, the cosine, let's say the cosine of that, cosine of theta equals adjacent over hypotenuse. Well, the adjacent ends up being just the x, so cosine of theta ends up being the x, and the hypotenuse ends up being the radius. So adjacent is x, hypotenuse is the radius. If we were trying to get what x is, we can multiply both sides by the radius and then get that r times cosine of theta equals x. So it turns out to find the coordinate or point or whatever of a particular function of a different radius, all you do is just simply multiply by that radius. Now before, our radius was just 1, so cosine of theta just equaled x. But if our radius is something else, all you do is just simply multiply that coordinate, and I'm off screen here. All you do is multiply that coordinate by whatever the radius is. So really, the only thing that changes from the previous lesson is if the radius is other than 1, you would just multiply the radius by whatever you got. So I'm going to show you what that looks like. So the first question here asks to find the exact coordinates meaning you cannot put this in your calculator. You need to use the unit circle to find exact coordinates, no decimals. Are located at the intersection of a circle with a radius 5 and a terminal side of 150 degrees. So if you look at your unit circle and find 150 degrees, I'm still not in there, at 150 degrees, you'll see that 150 degrees is somewhere over there. Okay, 150 degrees, a rotation of 150 degrees. Okay. If we are to find the coordinate of that of a radius 5, we're going to use these formulas. So r times cosine of theta equals x. And the same thing can be said for sine as well. If you're trying to find the sine, it's the exact same thing. Just r times sine of theta also equals x. So we're going to put everything in. The radius, okay, I'm going to flip this around just so it looks right. X equals the radius, they told us is 5, and then cosine of 150 degrees we can find on our unit circle. So I'm going to pull over the unit circle here. If we find the unit circle at 150 degrees, remember cosine is the x value, so it's just negative square root of 3 over 2. So really this is just x equals 5 times negative square root of 3 over 2. Or Remember, you just multiply times the top, so it would be x equals negative 5 radical 3 over 2. And that's the x coordinate. The y, again, I'm going to flip this around, same radius times the sine value of 150 degrees. From our periodic table, we go to 150 degrees. You see that the y value is 1/2. So 150 degrees is just 5 times 1/2, or 5 over 2. So, I don't know why this is x. Sine is y. Sine is y. Sine is y. Sine is y. So when you go to write your coordinate, it's an x comma y. So coordinate negative 5 radical 3 over 2 comma 5 over 2. So again, recap, find your trig function for that, or find the coordinate for that particular trig function on your unit circle, and then the formula is just whatever the radius is times whatever that is. So we did last time, we found cosine of 150 or sine of 150, no problem. Okay, so the only new thing here is then just multiplying the radius by that. So let's do this again. So again, we're going to find the coordinate of point P with a radius of 12 and so radius of 12, terminal side at 300 degrees. 300 degrees ends up being way over here if you look at your periodic table. So it's going all the way around. Oops, I don't know why I did that part. Going all the way around here, and this is 300 degrees. So again, the formulas for this are x equals r cosine theta and y equals r sine of theta. And we're just going to plug everything in. X equals the radius 12 times cosine of 300 degrees, which we can figure out, and y equals 12 sine of 300 degrees. Now, cosine at 300, we'll bring it in our unit circle. Here's 300 degrees. Cosine is 1/2. So this would be x equals 12 times 1/2, which is just 6. So x equals 6. Easy. Sine at 300 degrees is the y value, so negative radical 3 over 2. So I have y equals 12 times negative 3 radical 2. Negative radical 3 over 2. Right? Multiply by 12, you end up getting y equals negative 12 radical 3 over 2. That reduces to negative 6 radical 3. Write that as a coordinate, you get x comma y, so 6 comma negative 6 radical 3. And that is doing trig functions of different radiuses. On the back side, we're going to look at, well, what happens if we change up the angle instead of having the angle being one that's on our periodic table. Well, what do we do if the angle's not on our periodic table? And so this is done exactly the same way. The only difference is our unit circle is only good for specific angles like 30, 45, 60, 90, 135. So angles like 42 degrees 42 degrees is not on our unit circle. So what do? Here's where we have to use our calculator. Notice how here it says the coordinates of P to the nearest thousandth. So we're actually going to be calculating and not producing exact answers. So we're going to do exactly the same thing, just using our calculators. So when we do angle 42, It says that the intersection is on the unit circle. So this is point. It is on the unit circle. So that tells us that the radius is 1. Because it's on our unit circle, the radius is assumed to be 1. If we use our formula, x equals r cosine theta, and y equals r sine theta, we can figure out our coordinate. Since our radius is assumed to be 1, we don't really need it. So x is simply just the cosine of 42, and y is the sine of 42. So we can just plug those in our calculator. So I just we want to make sure that we're in degree mode. So mode, yep, we're in degree. So cosine of 42 is, we're going to go the nearest thousand, so 0.743. X equals 0.743. And y, so sine of 42 is 0.669. So y equals 0.669, and then all I do is write that as a coordinate. So my coordinate would be 0.743, comma 0.669. So same thing. And I'll let you do B here. It's exactly the same thing. We're assuming our radius is 1, so it's just cosine of 129 and sine of 129. Number 5, now we're going to do the exact same thing as we did above, but we're changing the radius to 4. So remember, nothing changes when you change the radius to a different number. All you'll do is just multiply the radius by that. So over here, x equals r cosine of theta. We already found cosine of theta to be 0.743. So all we need to do is just multiply our radius times that. So it's going to be 4 times cosine of 42. So I can do that in my calculator. 4 times cosine of 42. And it's just 4 times that value that I got above. So remember, the only thing that changes when you change the radius is you'll just multiply by that number. So 2.973. X equals 2.9. Oh, this one says, sorry. This one says to the nearest hundredth. So it is only just 2.97. And then our y equals sine, r sine theta will just be 4 times sine of 42. So 4 times sine 42, 2.68, y equals 2.68. There we go. So we can make our coordinate 2.97, comma 2.68. Okay, and the same thing for B. So the last example here is then, we're going full circle here. I'm going to zoom in here just because this is the only problem we're going to do for this. You can do number 2. It's exactly the same as this. But we're given very little information here, and it wants us to find the values of the other trig functions. So what we have to look here is, so we make a coordinate. It's saying that our angle is in quadrant 2. We don't know what the angle is. We just know that it is in quadrant 2. So that means, if you remember your quadrants, this is 1, this is 2, this is 3, and this is 4. It's somewhere over here. So we're going to draw an angle and make a right triangle. And here's theta. We don't know what it is. But it says that cosine of theta is -3/5. That means that the adjacent over the hypotenuse is -3/5. Now you don't know which one's negative, but we can assume that the hypotenuse is probably not going to be negative. It's actually, since it's a quadrant 2, the adjacent side that's negative. And then this is exactly what we did in the very first lesson. where you'll just complete the triangle and then just write all the trig ratios. So, we already have cosine, so sine of theta, and then tangent of theta, we already have cosine. Opposite of tangent is cosecant of theta, and then secant of theta is opposite of cosine, and then cotangent of theta. Well, if you complete the triangle, if you remember, this is a 3, 4, 5 triangle, but you could use Pythagorean theorem. It is a 3, 4, 5 triangle. So when I go to do the ratios, sine is opposite over hypotenuse, 4 over 5. That makes cosecant 5 over 4. Cosine is already negative 3 over 5, so secant will be just negative 5 over 3, because remember, they're just flipped. Tangent is opposite over adjacent, so 4 over negative 3. And then cotangent is the opposite of that, so negative 3 over 4. And that's it. So if you have any questions, let me know. Please don't hesitate to send me a message on Canvas or an email. If you're going through, there is a worksheet. I know there's no big ideas for this, so there is a worksheet. That is your assignment to go through and do some of the problems. So if you have any questions, please, please, please don't hesitate. And when I see you next time, we'll be reviewing for our unit test.